All right. Welcome again, everybody, to this FedOSC webinar in the Data 101 cycle titled 10 Ways to Make Your Data More Fair. I would like to start with a very brief presentation of the FedOSC project. FedOSC is a strategic initiative supported by BELSPO and operated by the Federal Scientific Institute together with .NET to promote open science practices, fair data practices, and to provide tools and resources to support those practices practically. So it's a very practical initiative. To go a little more into details, we are a team of data stewards, program managers, consultants, developers who are working on providing digital services like the MP Online or the Orfeo institutional repository, providing them and improving them. We are working on a data set inventory across our federal research ecosystem, working on the BELSPO open science policies, and working on training opportunities on the topics of open and fair data. And that is what we are doing today. We are a team of 5 data stewards who are more specifically working on this training work package, even though the FedOSC team is larger than that. My name is Judith. I am the cross-domain data steward. You will meet the other data stewards during this webinar too. We will have Marie-Sophie, Francis, and Anna who are here today. Our colleague Anne Rose is in charge of the arts cluster, and together we try and bring the FedOSC deliverables to life. I would like to redirect you to the Menti for a brief introduction about what we are calling today the data lifecycle. I would like to ask you the following question in the Mentimeter. According to your opinion and your experience, at what stage or stages of a research project does data come into play? You should be able to see the question on the Menti, and I'm going to give you a minute or so to start typing what you think is the right answer. Well, there is no right or wrong answer at this moment. I'm trying to keep the suspense alive, so I will show the responses in a moment. I can see a lot of participation. Thank you. About half the people have responded. I'm going to leave some more time for this. Maybe some last minute inspiration. Oops, my bad. Let's go back to the Menti. Okay. All right. All right, let's see. Oh, wait, there's more. It's really hard to be the one to decide when the Menti is over, but at some point, I will have to click on show responses. Okay, let's see what we've got here. At all stages, we have all stages quite a few times, all of them. At proposal stage, at the start, planning stage, so we have some responses that hint, one more here. Hint at, well, it's more a beginnings problem from the very beginning, indeed, at all stages. As soon as the data is available, okay, yeah, that's a good one, definitely, from the beginning to the end. I would tend to agree with the responses along the lines of at all stages, because indeed, alongside the life of a research project, research data has its own life cycle, actually. As you plan your research project, you will also need to be planning for the data that is best suited to answer your research question. Think about the data, well, before it exists, or think about the data you need before you start collecting it. When the data gets collected, you might still have to review the scope of your data sets and of your data needs a little bit. And as the project moves towards a more active and analytical phase, then the data lifecycle itself can move on to the processing and analysis stages that you can see here on the screen. By the way, this comes from a very handy tool that's called the RDM kit, Research Data Management Kit, that we will be using quite a few times throughout this presentation. When we get to a more mature project with some preliminary outputs or even final outputs, we might think about how to disseminate those outputs. Well, data is a research output in and of itself that can also be part of a preservation strategy and a sharing strategy. We can also reuse research data, which can be both a beginning and an end. Thinking about data reuse and reusing research data at the beginning of a project. Here are a few examples of some very concrete actions that we might be taking during the research data lifecycle. In case we are a little bit hesitant between the differences between processing and analysis, processing would be the digitization processing or the cleanup or the formatting or the tidying, cleaning processes of your data set before they go actually through a scientific analysis. So these are some examples to illustrate that. Preserving and sharing would be about storage, would be about documentation. We'll go through that in detail in the rest of the slideshow. This research data lifecycle is a cycle, it is circular, because we would love it if theoretically every research data that is produced could be used more than once. So data reuse will actually be at the core of the definition of the FAIR principles. And I would like now that we move to the definition of the FAIR principles. To do so, I will hand the microphone to my dear colleague Anna. And while we figure out the microphone handling stuff, I would like you to go back to the Menti because there will be a question for you in a few minutes. Anna, the floor is yours, and I will be manning the Menti in the meantime.
Okay, next slide when you can and where people are ready.
All right, so you should be able to see the question in your Menti. A little bit of a quiz. What does FAIR actually stand for? Okay, so we seem to have some quick answers there. Maybe a few more seconds. Let's not take it too seriously, of course. What do you think, Anna? Shall we reveal the answer now?
Yeah.
All right, let's go. FAIR actually stands for, yeah, right. Findable, accessible, interoperable, and reusable. I'm going to go back to the slideshow for you, my dear Anna.
Okay,
and
thanks.
You can help us unravel the mysteries of FAIR data.
Okay, so as most people have guessed, FAIR is a quite popular acronym, and we're talking about data, and basically it stands for findable, accessible, interoperable, and reusable data. And in practice, you can look at it as making your data discoverable by others, whether they're humans or machine, making your data available, so accessible to others, making them easy to integrate with other data, and making them easy to be reused by other people or machines. So these are principles that were drafted almost 10 years ago. But since then, they've been adopted by various organizations, and in Europe, I mean, the European Commission and many other policymakers have adopted them since the start. Next slide. So I'm going to show you a bit more what it means in terms of FAIR as guidelines. So FAIR data principles are basically guidelines in research data management. And this is something that means that in practice, you can apply them in handling your data, taking proper care of your research data. And this is done throughout, as Judith mentioned, the data lifecycle. So it's not only at the beginning, but in the long term. Then FAIR, making your data fair, it's basically a process. FAIR is a spectrum. You can have FAIR that are more or less fair data in a various degree of fairness. And then another important distinction is between open and fair. So actually, you can have fair data that are fully open, but they can also be restricted following the principle as open as possible, as close as necessary. So you can have authorization, you can have licenses to your data, and this doesn't prevent your data to be fair. Next slide, please. So today, the scope and focus of this webinar is to give you some practical hints on how to make your data more fair. As we said, it's a process. So you start from a certain degree of fairness and you try to improve it. The FAIR principles are not just a checklist. So it's really something that has a meaning and benefits both you as a researcher and the people that are going to be using your data. And the verification process, so making your data fairer, depends really on the type of data. It depends on the scientific community behind this data. So today, what we're going to show you, it's a few habits that you can adopt. Very simple. It's in your daily routine, so it's nothing that requires a lot of thinking. So the important thing to remember is that basically it's something you can do daily, and it's a continuous process toward progress. So your data will start to be better since the beginning. So next slide. So we said 10 is the way, and we start the first one. Next slide. This happens at the very first stage of the data cycle. So it's when planning, so thinking about how your data are going to be reused in the future, and you start to think about formats and what will happen once your data will be ready to be used by other people. So you will have to think about what will happen in a year, in 10 years, or even in a month. Who are the people or the systems that are going to be reusing my data? In the future, you have to think about the kind of format your data will be available in. So this is the time to make choices and the time to think about the most sustainable way of storing your data, for example. So this is really like planning ahead for the future of your data. There are some resources that we're providing you, and the bottom of each slide, you will see a list of useful resources that you will later can click on and have a look at. So just to let you know what's at the bottom. Next slide. Second, yeah, sorry, we have
No, you go, my dear. For the next slide, we're still going to go to the mentee because we would like to know who we are speaking with today, actually. And if you have any experience in, I want to say, creative or improper file management. So the question for you is, have you ever tried to reuse one of your own files, something you had written for yourself, something you had been working on yourself, after many months, could not make sense of it anymore? This will help Anna see in how much detail we need to address way number 2. I'm confident this crowd isn't no kind of crowd. You're all well documented, well versed, right? Let's see what you've told us. Okay, there's a little bit of confession there. I understand. So Anna, I think it's important that we go straight to way number 2.
Okay. So yeah, so the key message is being consistent and as much organized as you can in your daily activities. So make your data easier to find using, for example, file naming conventions that are easy to understand. So be consistent, yes. Use a short descriptive file name. Include, if possible, the date of creation using a standard format. So, for example, the ISO format for the date. Include a reference to the project. Include a version number, if possible. And so, in general, avoid using very long name. Avoid using something that it's really not easy to understand or misleading. And avoid using special characters that are sometimes a problem when switching from one operating system to the others. So this is general rules, and you can find plenty of other rules in the links that we provided. But I would say being consistent and having a way to name your files, it's already a first step in making your data more fair. So next slide, please. Then another important thing to remember, it's again, we said at the beginning, planning, thinking ahead of people that will be reusing, but also yourself. So it's documenting your data. And you can do that with a simple README file, which is usually a plain text file or a markdown file containing a minimum amount of information, but information that it's needed to understand the content of your data. So you usually, let's say you have a folder where you put all your files, you usually put in there a README file. You can add information like the name of the data set, the author of the data. So when it was created, again, remembering that using a consistent format for the date could be helpful. Stating the purpose of the data when possible, also including the software that have been used to create that data, if it has been processed or not, depending, using the version of that software, providing as much detail as possible. I mean, the minimal amount, but what is needed to recognize what kind of software was used. If you have already in mind the kind of type of license or application that you want to use, you can put it there. And also you can include the structure of the file. So explaining the naming convention, like the versioning convention, or explain the kind of units that are used within those files. So these kind of things can be more, can be less, but basically the idea of having a file that will help people understand what the content of that folders or the content of that files will be. So this is, again, very simple, and it can be done by anybody. So yet again, another simple tip, and then we go to the fourth tip. So next slide, please.
If that's okay, before we go to the fourth tip,
yes.
I would like to see if our participants today have already written a README file, because it's actually a small but powerful practice to put into place to like considerably boost the fairness of our data sets. So our question for you would be, have you ever written a README file? Or maybe you already have, but you didn't call it a README file. Maybe it was another practice. Let's see where you have responded. Oh, okay, okay. So it's something that you have already done. Well, maybe without even realizing it, you are already supporting the FAIR principles in your daily work. Anna, I hope you can allow me to do this, but I think that before we move on to the tip number 4, so that we make sure that everybody knows how important it is and that everybody is paying close attention, I would like to again go to the Menti and see if you believe the following story to be true or false. True or false? In 1998, a NASA Martian climate probe mission failed and crashed on the surface of Mars due to inconsistent data encoding. Do you think that story is true or false, and to what extent? Maybe 10 or 15 more seconds. I mean, it was 1998. So technically, it was before the FRE principles. Did you guess right? Let's see. 5 people guessed it right, indeed. The correct answer was true. NASA was actually using metrics units in mission preparation. And one of their providers, actually a private company, Lockheed Martin, was actually using imperial units. And that caused the Mars Climate Orbiter mission, which consisted of launching a probe, to fail and crash on the Martian surface. So FAIR saves lives and money because that probe was $500 million or something. There's a link to the Wikipedia article. So please pay close attention to what Anna is about to say, because it might save you quite a lot of money.
Okay, so this is an example talking about something that most of us would use in their daily life. It's tables. So when you're storing data in tables, like Excel files or whatever, you have to think about that as a structured way of storing your data. And for that, the more standardized you are, I mean, the more consistent in the use of naming and, for example, the variables, the better. So the more fair your data, because it would make it easier for other people and also for machine to read correctly, to parse correctly your data. So talking about tables as an example, a fair table we use, for example, one variable per column in a row. I mean, this is okay, basic best practice, but in any case, for example, you're expressing dates, keep using the ISO format for the date, for example, use control vocabulary when describing data, and for example, be consistent when you do not have any value in the table, use not available, use a string that would be the same throughout your table when referring to missing data. So these are just examples, but just to tell you that this is basically what we would need to do in general with structuring your data. Use a consistent way of expressing your terminology. So use formats, standard formats where available, and be consistent. Again, simple tip in your daily life. So I think I can hand it over to Francis for the next tip, number 5.
Francis, my dear, don't forget to turn your audio back on. We would like to hear what you have to say about version tracking, please.
Thanks. Yes, first I had to approve that my camera was on. Now my mic is on, and I think everybody can hear me. No, thank you, Anna, for the first 4 ways, and I'll continue with the next ones, and I'll start with number 5. So imagine you're working with a large group, multiple people editing the data at the same time, changes happening everywhere, and suddenly you're asking yourself, who changed this, when, and is this even the right version? Is it the last version? So that's exactly where version control comes in. And so instead of overwriting each other's work, you keep a history, you can track changes, understand what happened, and even go back if something breaks. Now, some tools already have it, and they help a bit. It's Word, Excel, Google Docs. They have track changes and version history, useful, but limited. On the other side, you have tools like Git, GitHub, GitLab, Bitbucket. They're very powerful. They have full traceability, but they're not always the easiest to use, especially for non-code files. There is maybe with the Jupyter Notebook a little sneak to get those into Git, but that's already again a bit more for the tech savvy people. Anyway, in between, there's also a whole range of tools depending on your workflow. Overleaf, RStudio, Notion, and others that integrate versioning smoothly as well. And if none of those are available, no problem. You can still do the basics. Clean version names, simple change logs, and of course, here an important piece of advice: never overwrite your only master file, because if it's gone, it's gone, or you might be in trouble. Next slide, please. So let's talk about tools for a moment. So when we mention FAIR principles, people often think it's all about data, but actually the tools and software you use also plays a huge role. So most research tools today also already support fairness to some extent. For example, they may use open formats, including metadata like headers, or keep version history, so that's all good. But here's an important point. Your software does not have to be open source or free. What really matters is the question: does it lock your data in, and can you get your data out? So for example, if you're using a lab instrument or specific software, just ask yourself the question: can you export your data in different formats, or are you stuck with one proprietary format? So same with everyday tools like Word or Excel. Can you also produce a more open version of your files when you need to share or publish them? A good sign for fair, friendly software is when it's allowed to have structured exports, and that's then mainly through APIs, and especially the REST-based ones. So here there's a key idea that's very simple. Don't focus too much on the tool specifically. Focus more on rather your data remains accessible and reusable. Yes, next slide.
For the next slide, Francis, we will continue talking about formats. You just talked about proprietary lock-in, and let's go back to the Menti for a moment. Dear participants, we would like to know in your daily work or in your research practice, what file formats do you usually encounter? You should see a text field in the Menti where you can fill out, and I will show the responses in a moment, maybe 30 seconds or so. More responses coming in. The word cloud is forming. We have many responses to analyze, actually. Maybe 10 or 15 more seconds. I think some people are still typing. Marie-Sophie, I can see that your hand is up.
Yeah, she wants us to continue.
Yeah, thank you. That's a very good convention. Okay, so I'm just going to go show responses. If you have more ideas or more formats that you want to talk about, please enter them in the chat. All right, what do you think of this? PDF, Excel, we have CSV, text, Jupyter Notebooks, JPEG. So we have images, text, tablet data. Wow, okay. I can see ODT there. That's the Open Office equivalent of Words, JSON, someone is a little bit tech savvy. Fits, do we have Astro people in the room? I think so. All right, thanks. Thanks for this information. The Menti will remain open. Please, let's go to tip number 7.
Yes. So yes, now let's talk a little bit about file formats. So it's something we all use, but we don't always think about. So first, an important thing, no format is ever 100% future-proof, but some are definitely more future-friendly than others. So in general, open and well-documented formats have a much higher chance of still being usable in the long term. And why? Because they don't depend on a single company to survive. Open formats usually have publicly available specifications. They work across different systems, are often based on plain text, so they're easier to read, share, and preserve. Now, compare it with proprietary formats. They can work perfectly fine today, but if the company changes, disappears, updates the software, even access to the data can become complicated. To make it more concrete, here are a couple of examples. So for text, formats like TXT, Markdown, or HTML are more open compared to things like doc, and pages, RTF. For tabular data, CSV or JSON are more sustainable than Excel files. And the same pattern applies across images, video, maps, even databases. So you don't have to memorize this. The idea is simple. Just be aware that for almost every data type, there's usually a more open alternative. So here, the takeaway is whenever possible, choose formats that are open, well documented, and not tied to a single tool, because it's what gives your data the best chance of being reusable, not today, but in the years to come. Next slide. And then there's also a bit of a nuance here because it's not always one size fits all. There are different research communities that have their different own standards. Like for instance, in astronomy, you see FITS, in medical and media, it's more like a DICOM, and in the arts, it's a IIIF. But that's no problem. That's perfectly fine because these are formats that are widely used, well documented, supported within those communities. So the goal isn't to avoid these formats, just to be aware that it's which standard is the one and which one is sustainable in your field. And then one more practical tip, even if your data isn't very human friendly, like raw or numerical data or complex files, in that case, it's always a good idea to provide a more accessible version. For example, you have a raw data set, you might include a simple image or plot, like a PNG, so people can understand what the data represents. So again, it's using the right standard formats for your field, and if needed, complete them with something that's easily like human interpretable. Yes, next slide.
For the next slide, actually, we're going to be talking to our audience again. You may have understood or witnessed that we are moving along the data lifecycle as we go into the 10 ways, and we are moving towards the more final steps of the data lifecycle. And we will be, for the final 3 ways that we want to discuss with you, we will be talking about metadata. And our first question to you is, do you have an up-to-date ORCID? Or if you don't know what an ORCID is, you also have that option. Oh, by the way, the Menti is anonymous. You don't really need to worry. Few more seconds, because you want to check. Browse to orchid.org, see if you're in there. Okay, I don't see any more responses coming in. Most of our audience today has an ORCID. Some of us need a little more explanation about what an ORCID is. So I suggest we go back to the slideshow and give it again over to Francis.
Yes, so let's move indeed into something that might sound a bit more technical, but it's actually very powerful. It's persistent identifiers, or bits. So think of a bit as a permanent, reliable link to something. Now, just a URL, it might always break, but it's a stable reference that will always point to the same object. So you've probably already seen some of these, and some of us maybe not, but they are like TOIs for papers, the ORCID IDs for researchers, or RORs IDs for organizations. So what makes them special is that they're globally unique and managed by trusted authorities. So they just don't disappear over time. Now, why does this matter for FAIR? Well, they make citations in the first place. They make them much easier, much clearer. You always know exactly what is referenced, and you can track and reuse. They also help with versioning, so you can distinguish which different versions exist of the same object. They connect data to metadata, which improves, again, the discoverability. And they support things like controlled vocabularies and authority files. So basically, making sure everybody speaks the same language when describing things. Let's see, there was, yeah. No, I should continue on the same slide. And I had something else. Just the most important thing is here, they give you a permanent access point. So even later on, someone can still reliably find what you created or what you're referring to. So here it's simple. Again, if you want to do research to remain it's findable and reusable over time, using persistent identifiers will definitely help in that. Voila. And then I think there's another question on persistent identifiers, if you all paid attention.
Thank you, Francis. I hope you paid attention, because indeed now we have a little quiz for you on the Menti. So PID is a globally unique, stable, and resolvable identifier. So knowing that, which of the following propositions do you think are PIDs? Let me launch the question for you. You will have a few propositions, and you can tick the ones that you think are PIDs. I'm going to give you maybe a minute for this one. Oh, there's no prize, and it's anonymous. So don't take this too seriously. All right, some responses are coming in. Thank you. Thanks for participating. Ten or 15 more seconds, maybe maximum. Thanks to our wonderful colleague Marie-Sophie, we are still on time. Let's try and keep it that way. All right. Okay. Someone is still a little bit hesitant. Okay, I'm going to click on show responses. See if you were right. All right, not too bad, not too bad. Great. Nobody got fooled by the project acronyms. That's awesome. Let me show you the correct answers. So in fact, the PIDs in the list would be the handles, the ISBN or ISSN that are managed by an authority, the ARCs, albeit they're a little bit lesser known, the Wikidata QIDs, and the RAID. RAID are actually a fairly new object compared to some other PIDs that have been out there longer. Those PIDs all have in common that they are minted and managed by an external authority and that they are sustainable and permanent. The other identifiers are either internal, local, like grant number or a local database ID or a project acronym, or non-permanent. But you did an amazing job. Great. Good responses. So Francis said that PID enable trustworthy citation. Let's continue talking about citation and dissemination, Francis, with tip number 9.
Yes, this one is a very practical but often overlooked aspect, usage rights. So because no matter how well you prepare your data, if people don't know what they're allowed to do with it, they simply won't know how to reuse it. So licensing is what this makes this clear. It tells others whether they can access, use, modify, or share your work. And importantly, fair does not mean everything has to be fully open, as was said by Anna in the beginning. So openness, it's a spectrum. So your data can still be fair, even with restrictions, as long as the conditions for access and reuse are clearly described. In practice, many people are going to use the Creative Commons licenses for this. It's a simple but effective step is to clearly state reuse conditions in a README file, if that is also a possibility, and was mentioned also in one of the other tips that we have. And also, if you're depositing data in a repository, a license is often required anyway. So here the message is make your usage rights explicit because clarity is what enables reuse. And then to the next one. Yes, in tip number 10, finally, let's talk about where your data then will actually live. A trusted data repository is more than just a storage. It's a place to preserve, share, and make your data discoverable. Good repositories support fairness by doing a few key things. They assign persistent identifiers provided with structured metadata. They allow you to add a license, ensure the long-term access. But there are different types. Your institute might have one. Some are domain specific. There are also general ones like Zenodo. Then maybe there's one important clarification. They're written in bold. Tools like SharePoint or Google Drives are not data repositories per se. They're often great for collaboration, but they don't ensure what we call the long-term preservation or discoverability in terms of the metadata and so on. So yeah, so these repositories, if we make use of them, they're not just for sharing your data, they're also a great place to find, existing data sets. So here, if you want your data to be truly fair, put it somewhere designed for it. And there's in the next slide, nothing extra actually. So, of course, this is, oh yeah, maybe we can go to the next slide. Yeah, this is just but a start. If you want to have more information in terms of how to assess whether your data is fair, there's a couple of links here. There's the ACME Fair. This is a guide for research performing organizations to have a look at. This guide, it's very useful. Then there's a Fair Aware to assess your knowledge of FAIR, as we've been doing a little bit here with the Menti as well. And then there's an interesting tool. It's a Fuji automated FAIR data assessment tool that you can also try out your data to see how fair your data sets are. And then there's also the FAIR data object assessment metrics, an interesting link. Then there's one on how to deal with sensitive data. It's a YouTube video. And I think I can finish to tell you all to stay tuned for more FedOSC Data one-on-one webinars. And I'll hand over again to Judith.
Thank you so much, Francis. Thanks a lot. Indeed, this Data 101 is actually a learning track. This 10 ways to make your data fair is the second workshop we are having in this learning track, and we will be having more about metadata, about PID, licensing. Basically, everything that we will have discussed during this webinar will very likely be discussed further in the Data 101 track. If you want to stay in touch, we will be providing links to our newsletter, LinkedIn groups, and we would be glad to see you there as well. I would like to provide you with a very brief recap. Basically, I hope that today you can grasp this take-home message that data lives in a life cycle alongside the research project, and it is involved at every step of a research work, from planning to disseminating, including analysis. Remember what Anna said also at the beginning of the presentation, fairness is not openness, and fairness is a spectrum. So those 10 ways are small bite-sized actions that you can take individually at different steps of the life cycle to different extents to continue fairifying your data sets. You will, of course, receive this slideshow, and we will be disseminating content on Zenodo, so you don't have to memorize it, and you can also adapt those tips and ways to the reality of your research projects. You may live in an institution that is lucky enough to have a data steward. They are also great people to help you make your data more fair. Before we finish off and move on to the Q&A, I would like to leave the Mentimeter open during the rest of this discussion to give you a possibility to let us know, please, what is one thing that you have learned today, or what is one thing that you want to act upon or implement. I will be leaving this Menti open, and we will be coming back to it during the Q&A, so please feel free to type in at your own pace. We would be happy to stay in touch with you. We would be happy to have you in our other Data 101 webinars. We are also hosting events outside of the Data 101 learning track, so please register to our mailing list, join our LinkedIn group, or just generally stay in touch with us with the address fedosc@belnet.be. And we will now be moving on to the Q&A session. Thank you, everybody, for staying up to here, and let's move to the Q&A.